All right. So, what on a position versus time graph tells us velocity? What on a position versus time graph tells us velocity? Slope. Okay. So, that tidbit of review. Answer that question. Thumbs up when you have a guess. Have a conversation.
Yeah. What is that? Which one? Yeah. This is like all these. These are all kinds of no, when I first saw this go, it's gonna be like awesome. I thought it was gonna stuff that
Correct answer is?
C.
Correct answer is C. Good job. So, steep or shallow? Steep corresponds with fast or slow? Fast. Okay, is it positive or negative? Positive slope. So fast, positive. Here, is the slope negative or positive? Still positive. Fast or slow? Slow because it's shallow. Are we good with that? Okay. Use this, the thinking that you did to answer this, to answer this. When you have a guess. Have a conversation.
yeah. No, if you just go over it. Well, no, at first I was no, I was like, it said like this was and then it's like you keep having so it's just like
Okay, what do you say? We got 1A. Correct answer is A. Here's my recommendation. Take it in chunks. Okay. Here is that steep or shallow? Shallow. Positive or negative slope? Negative. So is it going fast or slow? Here, this is slow, negative. Positive or negative? Negative. Steep or shallow? Steep. Fast or slow? Fast. The chunks mathematical term is the tangent, line tangent. Okay. Once you've divided those into chunks, then put the story together. Start slow in the negative direction and speed up. Good with that? Thumbs up, yes. Have a conversation.
So it's not a technically each one. It's not a moving, it's not easy because it's got no how much work you need. It's like an H thing. Yeah, it's the actual expansion. They're so tiny, but you know. You know, ask some questions, but yeah, the limit they gave us to is kind of confusing.
Okay, correct answer is? Correct answer is E. I do agree with that. So fast positive, slow positive. So you're slowing down in the positive direction. Good there? Recommendation is take it in chunks. Talk to your neighbor.
Yeah.
What do you think? Correct answer, D. Dangerous dinosaurs. All right, take it in chunks. Fast or slow? Fast, positive or negative? Negative. Fast or slow? Slow, positive or negative? Negative. Fast or slow? Slow, positive or negative? Positive. What had to have happened between this and this had to have stopped and turned around. In order for you to go in one direction and then go in the other, there's got to be a point where you're stopping. Okay, where did that happen? Right there, where the slope, the instantaneous slope would be 0 at some point. Okay, there. And then here, fast, positive. Good? You have an answer? Talking there.
Yeah. Yeah. No. Yeah.
Correct answer is? Correct answer is D. Dangerous dinosaurs. Slow negative, fast negative, slow negative. Okay. Quick confidence rating. Okay. Take some time to reflect on what you learned. Right? If there's anything that you picked up along the way, write that down. That, like this little exercise of reflecting, that's where the learning, like that's where you're capitalizing on your learning. Okay. I'm trying to teach you how to take good notes for the rest of your academic and really your job. If there's things you're like, oh, that's a good thing to write down. Okay. All right. Moving onward and upward. Switching gears. It's actually a substantial gear change going to velocity versus time graph. Rather than position, we're looking at velocity. Okay. please note what is on the y-axis. Have a conversation. Tell them why.
You're still at 2 seconds. Yeah.
Correct answer is? Correct answer is only B. Okay. Velocity versus time graph is going to tell you what your speedometer is doing and which way you're moving. Okay. Your speedometer says 0 meters a second. So you're not moving. But you don't know your location. You could be parked anywhere. Okay. It could be at the 0 meter, but it sure could not be as well. You don't know. This does not tell you position, your location. This just says what your speedometer is doing. Okay with that? Okay. So only B. Thumbs up when you have a guess. Okay. This question has proven not to be beneficial for you guys to talk to each other. I'm just going to tell you straight out. Okay. Correct answer is only A. Okay. Here's where the rest of these fall apart. Imagine that you're driving and you are going to merge onto I-65. So you're on an entrance ramp. At some point, your speedometer goes by 50 miles an hour. You okay with that? As you speed up. Now, does that mean that you've traveled 50 miles? No. But your rate is 50 miles an hour at that moment in time. You would travel 50 miles if you maintained that 50 miles an hour rate for an entire hour. Then you would have traveled 50 miles. But this just means your rate is going 50 miles an hour at that moment in time. That's just how fast you're going. Okay. At this moment in time, you're going 2 meters a second. In order to travel 2 meters, you need to do this speed, this velocity for an entire second, an entire 1 Mississippi, 1 second time interval. This is just a moment in time. This just says your speedometer says 2 meters a second at that moment. We don't know how far you went because this is just saying the rate. Okay, you would have gone 2 meters if you would have done 2 meters a second for an entire 1 second time interval, time duration. 1 Mississippi. You okay with that? Thumbs up if you have a guess. Have a conversation.
I'm still going fast since you're over on velocity. Just going in the opposite direction. Constant. Yeah. Right.
Correct answer is? Correct answer is C. Okay. This means you have some negative value made that up. Your speedometer is on cruise control. It's fixed at a certain speed, 20 meters a second. The negative means you're going in the negative direction. With speedometer locked in place at a constant value. Okay, you see it. So this is not a position versus time graph. If it was position versus time graph, A would be correct, but it's a velocity versus time graph, telling you what happens to your velocity. How we doing? Okay. If I could summarize velocity versus time graph. If you are above the x-axis, you're moving in the positive direction. If you're below the x-axis, then you're moving in the negative direction. Most people do not have a problem with this next thing I'm going to say. As you go this way, you get faster. That is intuitive for most people. Here's the part that gets sticky. As you go this way, you're going from 1 meter a second, 2 meters a second, 3 meters a second. you also get faster. That's the part that usually messes people up. So in summary, as you go away from the x-axis, you're getting faster. You go away from 0, you're getting faster. As you go towards 0, as you go towards the x-axis, you're getting slower. Okay. I know I didn't give you numbers, but make it a relative scale here, relative to each other. Thumbs up when you have a guess. Have a conversation. Tell them why.
It could also, yeah. Oh, right. Oh, concentration. Concentration. I think it's yeah, it's D. It's D or A, probably. Yeah.
Correct answer is D. Dangerous dinosaurs. Okay. Negative direction. So we're below the x-axis. If this is a position versus time graph, B would be correct. But it's not. It's a velocity versus time graph. So we're moving at a constant speed. We're locking in our, like we've got cruise control on, heading in the negative direction. It's D rather than E because E is further away from 0. This is closer to 0. Good at that. Learning stuff. Tell your neighbor. Correct answer is C. How are we doing? Okay. Here's my recommendation on how to do this. Instead of taking chunks, pick points. And then make up values. Here, going 0 meters a second. Here, I'm going 1 meter per second in the negative direction. Here, I'm going 2 meters a second in the negative direction. And then put those together, connect the dots. Started at rest, I sped up, I'm getting faster and faster, all in the negative direction. Okay, let me give a little insight to you on how I teach this class. I purposely order the questions to be increasingly more difficult. Okay, initially I'm giving you training wheels, and I'm running alongside of you. Yeah. And at some point, though, I'm sticking you on an off-roading mountain biking trail. Okay. I'm trying to teach you the techniques while you're in the training wheel mode. And if you employ these techniques, you'll be able to take on the off-roading courses. Because on the tests, I'm notorious for throwing off-roading question after off-roading question. Speaking of tests, not tomorrow, but in a week from tomorrow. Okay, good with that? Yes. Talk to your neighbor.
It's not speaking with increasingly speeding up.
You can see it's starting fast and slow.
Your velocity gain more.
And then get faster. It's like constant. So I yeah.
Correct answer is? Correct answer is A. D is speeding up in the positive direction, but it's not at a constant rate. Okay. Thumbs up when you have a guess. Compare and contrast answers. Definitely explain.
Slowing down at a house.
But he is slowing down too, but it's going in the right direction.
Right, would be. Because you would
You say he also.
Yeah.
If it's above the line, it's always positive, right? Yeah, the only thing that's gonna slow down is getting slower.
Yeah, but it's moving towards.
Correct answer is correct answer is E. Okay, pick points. This is usually a question like, oh, that was rough. Two meters a second in the negative direction. 1 meter a second in the negative direction. 0 meters a second in the negative direction. Putting that all together, you start fast in the negative and slow down. Moving towards 0 meters a second, moving towards the x-axis. How we doing? Thumbs up. Talk. Correct answer is E. Okay. Fast in the negative. Slow in the negative. Bless you. What happened in this chunk? Slowed down, stopped, turned around, and went in the other direction. We switched from negative direction to positive direction. Seeing that? And then we increased speed in the positive direction. Pick points. Thumbs up when you have an answer. Have a conversation. Correct answer is? Here we go, B. Tell your neighbor what happens there. Do you change direction? No. Why not? You're always above the x-axis. Good with that? Take some time to reflect on what you've learned. Just give you this insight. Doing this, what you just did there, for the rest of your academic career, be a good idea. Like right after class, like in college, or not, like try to like summarize what you like, or pull out nuggets that you just learned. Yeah? All right. Ready to go to the next level? I give you a position versus time graph, and you give me the velocity versus time graph. Thumbs up when you have a guess. Have a conversation.
Stacks, that means the velocity can't be moved.
It's high on position, it still has 0 velocity. Going up and down.
Velocity is not existent.
Yeah, exactly.
So,
What?
well, I asked you, so it's so big, how would you magnetize that means that will, direction is it's moving by itself. That's the difference.
Correct answer is B. Beautiful butterflies. What on a position versus time graph tells you velocity? Slope. The slope of a position versus time graph tells you the value of velocity. What is the slope of this line? 0. Therefore, the value of velocity is 0. Okay. neighbor? Tell them why. Correct answer is? How'd you describe the slope?
Constant in the negative direction.
Okay, it's a negative slope and it's a constant value. Constant value. That's negative. A is the correct answer. How are we doing? Yep. That's as far as we got with the other classes. So, got a worksheet due tomorrow.